Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 612. Please turn to it, page number 612. Today is our lesson number 58. Let's take a look at it. We are told that we have this quadratic function g of x, we are told, equals ax squared plus bx plus c. We also told that a and c are negative. And the question simply is, which of the following graphs that they give us, the 5 graphs, among the 5 graphs that they give us, which of the following could be the graph of this equation? Let's find out, shall we? Here's the equation here. G of x, we are told, is equal to x squared plus bx plus c. What we need to do here is define its y-coordinate, y-intercept. Let's see what happens here. Y-intercept is where x is equal to 0. Let's find out what the value of the function is when x is equal to 0. When x is equal to 0, it's going to be this guy right here, because it's going to be a times 0 squared plus b times 0 plus c, which of course is c, which we are told is negative. So we're looking for a graph where the y-intercept is negative. We're looking for a graph where we need a graph which has negative y-intercept. Y-intercept is where x is 0. When x is 0, the value of the function is c, and we are told that c is negative. So that's all it is. We're going to go through all the choices one by one until we find one that has a negative y-intercept. I need the room, so I need to erase everything here. Let's start, shall we? If we look at answer choice E looks something like this. The graph goes like this. Here is the intercept. The y-intercept is positive. The graph cuts the y-axis. The graph cuts the y-axis as a positive value. We just concluded that we need a negative y-intercept. E is not the answer. E is not the answer. Let's look at D. D says, again, it looks something like this. It has a positive y-intercept. You see, this is the positive y-intercept. It cuts the graph at a positive value of y. When x is equal to 0, y is positive. We need a negative y-intercept. D is not the answer. Let's look at C. In C, the y-intercept is at the origin. It goes through the origin. That's not it. We need a negative y-intercept. Let's look at B. In B, again it goes through the origin. It goes through the origin. It doesn't have a negative y-intercept. The answer is A, because in A, the graph that they give us does indeed have a negative y-intercept right here. This is your value of C. This is your C. And the coordinates of this point are 0 and C. That's it. We were looking for a graph with a negative y-intercept. We found it. The answer is A. Let's do the next one, shall we? Number 12. Number 12. In number 12, we are given a picture here. Let's reproduce it here. It's a rectangle. A, B, C, D. We're given a point P here, point Q here, and a point R here somewhere. Let's see what they're told. And there's a notation there that it is not drawn to scale. So we can't just go by the mere location of point P, Q, and R, try to eyeball it. It's not going to work. It's not drawn to scale. In the picture above, ABC is a rectangle, so it is a rectangle. We are told that B to C is 4. Alright, B to C is 4. Okay. A to B is 6. What is A to B? A to B is 6. Alright. P, Q and R are different points on the line, not shown. That is parallel to AD. Here's your A to D. I'm going to draw this AD a little bit better because it's a little bit slanted. I don't like it. There you go. There you go. As the saying goes, a little bit of cosmetic surgery never hurt anybody. It looks a little pretty. I'm being silly, you understand? So, P, Q and R are different points on a line that is not shown, but we are told that it is parallel to A to D. So we're going to draw our own line. Here's A to D. We're going to draw a line going through P, Q, R. As you can see, it is parallel to D. So far, so good. Point P and Q are symmetric. All of this information is crucial, you understand? You must pay attention to every single bit of it because everything is important here. The next part they tell us is that point P and Q are symmetric about line AB. Here's the line AB, and point P and Q are symmetric. What does it mean? That means the distance from point P to this point, let's call it, I'm going to call this, we have P, Q, R, I'm going to call it X. Let's just call it point X here, right here. So what they have told us is that P to X is same as X to Q. The distance from this distance right here, this distance right here is same as this distance right here. Because they are symmetric about line AB, they tell us. You must understand all of this thing. Point Q and R are symmetric about line CD. Alright, point Q and R are symmetric about line CD. So the way I drew it does not look very symmetric, does it? We have to extend it out. Not that it matters, it's not drawn to scale, you understand? But still, here is our point R, and let's call this thing, I'm going to call this thing Y. So we also know now that Q to Y is equal to Y to R. Q to QY is equal to Y to R. What the hell are they asking? Alright. Finally, the question simply is, what's the length of P to R? Alright, what's the length of P to R? So what we're going to do here is going to make up some number from this distance here, P to X, to start out with. Let's pretend that P to X is 1. If P to X is 1, then Q to X is 1. If Q to X is 1, let's go systematically. Let's pretend that P to X is 1. That would imply that Q to X, that would imply that X to Q is also 1. Because P and Q are symmetric about line AB. That means distance from P to X is same as X to Q. If X to Q is 1, then Q to Y must be 3. Because the whole distance from B to C is 4. That implies the distance from Q to Y must equal 3. If the distance from Q to Y is 3, that in turn implies the distance from Y to R must also be 3. Because Q and R, we are told, are symmetric about line CD, which is what we made notation here. Distance Q to Y is same as Y to R. This distance Q to Y is same as Y to R. That's it, we are done. The question was asking, what's the length of P to R? We just found distance from P to R is going to be, distance from P to R is right here in front of us. Okay, watch here. Distance from P to R is equal to Px plus Qx plus Qy plus Yr. That's it. Px to Qx to Qy to Yr. And that entire distance is P to R, which is 1 plus 1 is 2 plus 6 is 8. That's it. That's it. The answer is 8. What we should also understand here is that, you see, we just pretended. We just said, let's pretend that P to X is 1. Nothing would have changed if we had pretended a different number here. But 1 seemed to me like a reasonable number the way it's drawn here, even though it's not drawn to scale, they tell us. But still, I thought the way it's put in front of us, that distance to me looked like 1. But if we had pretended that p to x is 2, nothing would have changed. Nothing would have changed. Let's see what would have happened. We're going to redo the problem. Just to show you that the answer is not going to change. So now we're going to pretend that p to x is 2. If p to x is 2, then x to q must also be 2. X to q must also be 2 because they are equal. If x to q is 2 and b to c is 4, therefore q to y must also be 2. If q to y is 2, then so must be y to r, because q to y is same as y to r. There you go. You see 2 plus 2 plus 2 plus 2, p to r is 8. It's not going to change. That's it. The answer is 8, which is answer choice B. This was an interesting question, wasn't it? I'll see you tomorrow, okay? Bye now.